Now with the parallax unit ready, we can go back and fill in our build function. As a precaution in our build function, we'll remove any children, as there shouldn't be any prior to the build. And we'll set our background container's array's length to 0 to make sure it's empty. Next we'll make a for loop with an iteration for every layer there is to our background. So const ln int equals backgrounds.length. And then in our for loop, we'll decompile our background array and create individual elements from it. We'll also scale the elements to match our stage width. So const bd background descriptor equals underscore backgrounds, whichever iteration we're on, as background descriptor. Const current, which is going to be a display object, equals bd.background, which is our current iteration's background. And then const scale number dot stage ref stage width, which is our stage width, divided by our current width, which is to say divided by our unscaled background image's width, and const current scaled, which is the display object, equals bitmap tools get scaled bitmap, which scales a bitmap automatically. We take the image and we insert the scale we want, and then const clone bitmap equals bitmap tools.create bitmap from our current scaled display object. We'll also take this image and flip it. Current scaled.scalex equals bd.reverse question mark -1 colon 1 const fl sprite equals new sprite, and we're going to add the current scaled image to our fl sprite, and we'll create a const called flipped, which will be a bitmap, and it'll equal our bitmap tools create bitmap from our fl sprite. This simply flips the image. Next we'll take these two images, the original and the reversed, and pass it through to a parallax unit that we'll simply call parallax. Const parallax, we're going to invoke our internal class parallax unit. We're going to pass through our cloned image and our flipped image, and background containers.push will push through our parallax object, and of course add it to the stage. And we'll add a switch case to determine alignment of our parallax unit to either the top or bottom, as I previously mentioned. bd.type, which is passed through in the function. Case top, parallax.y equals 0, so we'll align it to the top of the screen. Or the default, which is the bottom. Parallax y equals GUI module settings. Dot stage height minus parallax height. So we'll set it to the bottom of the screen. We can close off the for loop and add a simple line of code to reverse our array to make sure the Z order is correct and not backwards. Let's type background containers dot reverse. Otherwise, our background layer will appear first in front of our foreground layers. You can see we use our convention again and make use of a variable called top in our switch case to indicate a top string. So let's go ahead and create those static variables. Public static const top, which is a string equal to the word top, and let's create one for bottom too. Almost done. Let's return to our iAdvanceAbleAdvance function and create a multiplier variable to help us make our different background layers move at different speeds. We'll set it to 1. And we're going to add a for loop with an iteration for each layer of our parallax background that multiplies the speed by the parallax speed reduction. We'll also reference our created parallax unit inside of our background container array and pass through this speed. Parallax unit equals underscore background containers for the current iteration, and we're going to invoke it as a parallax unit. And we'll take that current parallax unit and invoke its advance function, which we created, and we'll pass through the speed times the multiplier. So with each iteration, our multiplier will increase the speed that the background layer is passing by. Now let's override a public function called destroy. And we're going to invoke the supers destroy function. And we're going to remove all the children. This is just for cleanup. And we're going to set our arrays to 0. And let's also create an ignite function to start the animation. First I'll create a new variable quickly, which is a running boolean. I'll set it to false. And inside our public function, I'm going to submit the animation to the animator, and I'm going to set running to true. Running here is just synonymous with swimming. Thank you for watching.